I brought just a poster so it's easier to explain because we are at the end of the cycle. We already did the sampling and all the measurements, so this is a bit in not very good shape now, but anyway I can show you the plots. And this is the Portuguese site of the NutNet. NutNet is a nutrient network, and it's a really interesting global research cooperative that you can see here, the dots in the world. These are sites like this one. Now we have almost 80 sites around the world in 5 continents, and so you can see over here Companhia das Lusíadas in Portugal. And the idea, this began in most of the sites in the States. It began in the United States. And the idea started from a group of postdocs that were a bit stressed because they were not able to answer global questions mainly on biodiversity and productivity and herbivory and nutrient addition. And so they decided to begin a low-cost project. So it was an experimental design that was not so costly to establish. And so the dissemination began, and now it began with 20 sites, and now it's more than 80 sites in Australia and South Africa, a lot of them in the United States, but in Chile, Argentina,
Aurora is from Chile.
China.
Well,
Okay.
in Chile, but
You know NutNet? Okay, good. All right, so the global research questions, the main ones that began, were first one, how global is our current understanding of productivity diversity relationships? The other one, to what extent are plant production and diversity co-limited by multiple nutrients in herbaceous dominated communities? And under what conditions do grazers or fertilization control plant biomass diversity and composition? So what we manipulate here is the nutrient addition and herbivory. Although this site it's not very strong in terms of effects of herbivory, because we had to fence all the plots, because generally this is grazed by cattle, and it's a heavy graze in a short time period. So to maintain the plots we had to have this kind of fencing that exists also in several other NutNet sites. And we have some fences inside just to exclude rabbits, but rabbits were really low, so there was not really an effect for a long time. And so the treatments, and this is the experimental design that is general for every site. We here have one more treatment. It was a legume-rich sown pastures that we also had some plots. But the treatment is a factorial design with nitrogen addition, phosphorus addition, and potassium with micronutrients. And so this is in a factorial design. You can see that we have control plots. We have plots with just nitrogen, with nitrogen and phosphorus, and potassium in all possible combinations. And so in all these sites there is this standardized experimental design and also protocols. There was a first year where the biomass and species composition was just assessed before establishing any treatment. So this was the pre-treatment biomass and species composition measurement, and it was also done in all sites. And after that, this is the general design that we have also here. We have 3 blocks with 36 grassland plots of 5 by 5 meters. And we have these fertilization treatments. We use in all sites the same type of fertilizers and the same amounts, of course. And these are the basic measurements. These are every year we have to measure the annual productivity, annual biomass, the species composition and diversity, and also the septometer measurement, so the Wayfarer index. And after this, depending on the sites, there are several add-on projects, like for example lately, last year, we measured here, for example, nitrogen mineralization. Not all sites did this type of study, but a lot of them did. And for example, assessment of the composition of litter, or for example, this one is beginning now. We are studying the effect of this, in our case, 5 year of fertilization on the seed bank of the grasslands. Most part of these sites have 10 years. They have a decade now of treatment. This site has 5 years of treatment application. And so I've just put here some of the results just in terms of biomass and just for this site. So you can see that the number, we have here the number of added nutrients. So here the control plots, here the plots with just one addition of nitrogen or phosphorus or potassium, and here the three together. And for 4 years, so 2017 is missing here, but you can see that there is always an increase in productivity, but it's very dependent on the year that we have in consideration, because climate has really a big effect on the results. And so over here you can see the above ground in orange. In honor of you, it's nitrogen, so you can distinguish the effect of the nutrient that you are studying. And what do you think about this result, considering nitrogen? Can you do some analysis for me? You are the experts. So you have here 2013, this is the average production per square meter. It's here missing the square meter. So 2013, 2015 was a low productivity year. It was a quite dry year. So you have 152 grams in average of production here. 2015 was even lower, but also because we had a problem and the cows were so hungry that they really forced and they came in. So in February they came in and they ate everything. At least it was very homogeneous. So we have here a double effect of drought and herbivory. And 2014 and 16 was a quite normal year with these productions of 500, 400 grams per square meter.
Sorry?
And
I don't see well, but are the axes the same?
sorry, no, the scale is not the same, not at all, no.
So you go to...
So this is much lower.
What is the axis, the maximum value?
Over here is 300, over here is 1,200.
Ah, okay.
These ones are 300, these ones are 1,200. And this 2017 was also a very, very dry year. So I think we will perhaps have even lower than this 2015. So what can you tell me about the nitrogen effect on this grassland? The orange one, so explaining, the C is the control plot. So with this is the above ground biomass with no nutrient addition. This is with the potassium addition over here. This is with the nitrogen. These are the plots where we just added nitrogen. This is with the phosphorus. This is with the phosphorus and potassium, nitrogen and potassium, nitrogen and phosphorus, nitrogen, phosphorus and potassium. So do you think this is a limited, nutrient limited grassland or not? Yeah, no doubt. There is really a good answer to this fertilization application. And what was the best result on this? It was with the where you added all the nutrients. It makes some sense. Although in all the NutNet, 76 of the sites had this kind of effect. So there was an increase in productivity with the number of added nutrients, but around 26 of them had no reply to the addition of nutrients, so they were not limited by nutrients.
Sorry, how much concentration you're adding in your...
100 of nitrogen,
Yeah.
100 kilograms per hectare per year.
hectare,
Yes, the potassium and micronutrients were just added at the beginning, and they were not added anymore. And also the phosphorus, it's added annually, but potassium and micronutrients, no, because we were afraid of toxicity levels. And so we are studying now what to do after this time, if it will be added again or not.
So 5 years ago.
5 years ago, yes.
I have a question. Have you studied the underground biomass?
Yes, in some sites, yes, we did analysis of the soil and also root analysis, but not every year.
Because I was reading on in a paper where they say most of the time when they add the fertilization, it's like the allocation that changed. It's not the productivity itself. So plants don't allocate anymore in the underground, in the roots for looking for nutrients since they have them already. So they are going to allocate more on the above.
On the above ground, yes, that can happen, but there is a difference indeed in the above ground biomass also. There are also difference in species composition and also in diversity. There is a decrease in diversity with increased nutrient addition. Although once more these results are not global everywhere. There are some. The thing is, this relationship between the productivity and diversity depends also in a lot of factors that are content dependent. They depend on the sites. But the strength of this kind of approach is that you really have the same design, the same measurements in a lot of places in the world, so you can disentangle many of these factors. And one of the things that has been a debate in this diversity, productivity, ecological theme, and that came out of here is indeed that with more diversity you have more a higher productivity in general. Although it doesn't, it's not the same relationship. A bigger productivity not always indicates a higher diversity, because once more it depends on the soils, on if it's a dry site or not. Even you can see over here in our typical Mediterranean climate, you have a lot of variability on these effects. So you have these dry years with really a low effect of nutrients, and with the wetter years they have a bigger reply. So we can see now the plots, although, and you can por aqui está a ver no chão. É o melhor é deitar para ele não voar quando está. Okay, if you want to, you can come in, you can step in. So just be aware, because there is these small poles, wooden poles. For example, this is plot 36, and it was added just with potassium and micronutrients. So you can go around and check. So this is one block, there's another one there, and another one. And we already did the phenology was quite early this year, because it was a hot year and also very dry. So we had to sample earlier, for biomass and species composition. That's why you see some plots around. Another add-on project is to measure the 15N to see how the 15N gives you an idea of the source of the nitrogen and the legumes have a very specific signal. Really dry, and they are more sensible, so it was not just because you need water at the beginning of the season, and also still some warm temperatures, and those were not the ideal conditions, and I suppose that ones that germinate just were dead quite soon because there was no water for a long time. It just rained some weeks ago, some last week or two, because it was really dry for almost all the winter.
And are you able to keep track of the nutrient leaching from plot to plot?
No, from plot to plot, no. I'm not sure if that can be an effect, but I'm not sure if it is happening or not, but it can. Although, as here, this is a really sandy soil, so it really infiltrates very well, and it doesn't rain so much. So I don't think that is a problem. Perhaps in other sites can be. I don't know. Actually, it's a good question. I don't know if anybody thought of that.
Yeah, because the plots are so close together with different kind of nutrients.
Yes.
Could be a mix.
In some sort of soils, it
Yes.
could eventually be a problem depending on topography also. Yeah. Over here, I doubt it would be because of that. It's really any drop just goes really down. But,
have you seen any atypical or invasive species, or is it shifts within the balance of what you'd expect to find here?
over here, I think it's under the range. We don't have a lot. This is also inside Companhia. This is a kind of reserve of natural grasslands. Overall, in NutNet, what has been observed is that indeed with the nutrient addition there is an increase of non-native species, and there is a competition display, and also depends. They have a bigger effect in wetter sites and warmer sites, which also makes some sense. So there is an interaction between the nutrient addition and climate.
Just another question about the network. The concentration of the editions. I suppose that they are different.
No, they are not. They
They
are
are
just the same
They are the
everywhere.
same for all the sites.
Yes. One of the strengths and that we are always trying to keep is the design has to be exactly the same, the amounts the same. That's why we have the compromise of using exactly the same fertilizer. Sometimes it's not easy between countries, and also exactly the same experimental protocols. You have some, for example, some NetNets that have more blocks, more plots. And for example, we tried here to have a different one added treatment that was the legume-rich pastures, but for some reason we didn't manage to have a success with that. So you can have those add-ons, but the basic design is 3 blocks with these exactly treatments.